quick, like 1 minute thing about next generation, and I'm gonna hand it off to you, and you take care of the rest.
Okay.
Okay? You got it? Okay.
Break anything.
And you just gotta make sure that you help people get hooked up. You're okay with that?
Yeah.
Okay. Okay, great. So I'm gonna be like going back and forth between here and the workshop space.
Okay.
Well, thank you for doing this.
Yeah, you're welcome.
Yeah.
I'm happy to be here instead of, where I live and have a boring weekend. I would rather be here.
Yeah, this is exciting.
This is an awful weekend.
You?
I have the SAT.
You have the SAT?
Yeah.
Oh, yeah.
I think
Awful
another,
weekend.
you have another classmate speaking as well, right?
Jeremy?
No.
Who?
Is it Alana? Alana? Is she Polytechnic
I don't
as well?
know.
Or no, she might be another. Okay.
Andrew, Lynn, Jonah, Brady, Alexander, Alana are all in this room. So if you recognize them.
No, maybe not. Maybe you're the
what,
only
what
one.
last name for Alexander?
Moral?
No.
Morale?
I think it's just me though.
Well, regardless, have fun.
All right, we'll try. I'll try to talk. I'll try to go over, but it won't go.
Okay. Well, strive for it.
We'll strive for above 30 minutes,
Okay, yes.
which will be
Oh, wow,
okay.
this is gonna be a
I'll
hard
just say a bunch of
count.
things that mean nothing.
Are you supposed to take a head count too?
I don't know where to stand. I'll stand right here.
You're the proctor. Yeah. I mean,
You're the presenter.
yeah.
We're doing that again.
Is it time?
It's like 40 seconds till time.
Oh, okay. Are you okay?
Yeah.
You a little nervous?
A little bit.
Yeah, just
We'll
a
get
little
through
bit.
it.
Yeah,
We'll
you
get
will.
through it.
Yeah. So there's some water in there, okay?
Okay.
Yeah, if you need water.
Sure, like, let's go.
Yeah.
Reminds me of my grandma's house.
You'll be great.
We'll see.
We can probably get started.
Yeah. Isn't she supposed to?
Yeah.
Okay. It's 1:15.
Good? We're going to start. Are you ready? Yeah? Okay. Okay, hello everyone. Thank you for being here. Welcome to the Next Generation track at Southern California Linux Expo. So we have an exciting lineup of speakers, and we also have the P&G workshop space, which is next door. There are a lot of hands-on opportunities for students to engage in, so please, when you have a chance, check it out. We have August, who is going to be kicking us off with the first presentation of P&G, and then Charlie's going to be the room proctor, so she will also introduce him. So go ahead, Charlie. So thank you for being here.
Hello, thank you so much for coming to SCaLE X22. Today we have August Cho presenting Making Linux from Scratch. So yeah, please give him a warm round of applause.
Okay, so, I mean, you can probably figure out what I'm going to be talking about based on the name of the slideshow. We're going to be going through the story of how I did Linux from scratch, how you might do Linux from scratch if you choose to do it yourself. I'll give a few disclaimers. Number one is that I am presenting on a MacBook. I would have brought my framework had the drivers not broken on me, and so I apologize for that, given that we're at a Linux convention. Number two is that I had marked this presentation for all levels of experience, but a lot of the things that I end up doing inside of Linux from scratch are very complex, and I actually don't understand a lot of them myself. So I'm going to try my best to explain them, but if you don't understand, it's probably my fault. And number three is that I've timed this presentation, and I have 45 minutes to complete it, and we're going to go way under. So, sorry. So let's get started. Okay, in order to start making Linux from scratch, it might sound a little silly, but we have to actually define what is Linux, because it's kind of a misconception. So, you know, when people think of Linux, you know, those who haven't completely lost their minds already, right? You might think of Linux as this third kind of, we say it's an operating system, but computer environment, if that makes any sense. You know, you might have MacBooks with Mac OS, and you might have a PC with Windows, and then you have something else running this mysterious thing called Linux, right? It might be this third option on the downloads page of whatever application you're trying to install. If you're installing something for Windows, it'll give you like an MSI file. If you're installing something for Mac OS, you'll get a DMG. And if you're installing something for Linux, it'll give you a bunch of scary commands that you want to stay as far away from as you can, right? You might also think of the penguin, right? But if you're a little more, you know, if you've lost your mind a little more, and you understand more about Linux, then you might think of a collection of different things that we call Linux distributions. So when we refer to Linux, this giant web of different distinct operating systems, that's what we're normally referring to, right? These are all operating systems in the same way that Mac OS is its own operating system. It's just that we call them all Linux. They share code between each other, you know, and you can see they all kind of go back to a singular point, which would make you think that Linux itself is its own original operating system, but it's not. So Linux refers to a program on the computer called a kernel, right? The Linux kernel sits on top of your computer's hardware, the you know, the motherboard, the bare metal, as we say, and it sits on top of that and provides almost a language for software on top of it to communicate with the hardware, right? It provides things like system calls and allows programs to be more easily written, right? And so the Linux kernel is just a kernel application that is free and open source, which means that anyone can, you know, modify the code, use the code, take it and put it in their own projects. And because of that, because it's accessible, all of these different operating systems use it out of convenience under the hood. And because they use Linux, the Linux kernel, we call them all Linux as if it's one concept, right? And so, given that definition of a Linux distribution, that makes our job really easy if we're trying to make one from scratch. All we have to do is create an operating system that uses the Linux kernel. And there's no other requirement, right? We don't have to make it fancy. We don't have to have even a desktop per se, right? We just need to have the Linux kernel under the hood. And it gets even easier because someone has already written a book about it. So if you go to linuxfromscratch.org, this programmer named Gerald Beekmans has written this. I mean, he calls it a book, but it's really just like a giant collection of web pages. And it goes step by step, command by command, through the process of installing and creating your own Linux distribution with the bare minimum amount of programs, the bare minimum that you need to get started, right? And then, you know, given that information, you might say, oh, well, gee, August, that sounds pretty easy. It sounds like, you know, that's gonna, if you have a book walking you through, that's not gonna take very long at all, is it now? And I said that too. I said, okay, that's gonna take, you know, a couple days, right? And you would think that, wouldn't you? So days 1 through 3. So in order to get Linux from scratch working, you have to inconveniently already have Linux on your computer. Now, as someone who's not completely insane, I don't run Linux every day on my computer. I'd like it so that when I take my SAT, Blue Book doesn't completely crash on me because the College Board hasn't written code that completely, understands the workings of Debian, right? And then everything blows up and everything's ruined. So I don't run Linux on my computer every day. That's a problem because I need that to get started. So I said, okay, how am I gonna install a version of Linux on my computer without completely nuking my hard drive, right? And so I said, okay, we're gonna take something called a virtual machine and install Linux on that. Now what's a virtual machine? It does exactly what it sounds like. It's a piece of software that creates a computer inside your computer, and on that computer in your computer, you can run any programs you want. You can install whatever operating system you want. Okay, so we're gonna take this virtual machine inside a virtual box. We're going to install a Linux distribution that I already know onto that machine, and then we're gonna use that virtual machine to create Linux from scratch. Did I lose anyone? Okay, good. So then comes another problem, because if we're trying to install Linux on a virtual machine, on a computer inside my computer, it's gonna take up a lot of space on my hard drive. And I like my space on my hard drive. I don't want Linux from scratch taking 500 gigabytes of storage, right? So I said, okay, I need to find a Linux distribution that's gonna take up the minimum amount of space possible, right? And that's perfect, because I'm already quite familiar with the Linux distribution Debian. It's very popular. A lot of distributions have their code that originates from Debian, and I'm very familiar using Debian with only the command line. That means no graphics, no desktop, right? We're gonna run it in text-only mode, and if we do that, I'm gonna save so much space on my hard drive. Well, that's perfect, so I said. So I'm gonna install Debian, I'm gonna get the disk image, I'm gonna put it into the virtual machine. That's what I did here. It's gonna install itself, and then it actually installs a desktop for me without me. I didn't tell it to do that, but it installed graphics. I said, okay, I don't want graphics. I want to have it be text-only mode, so I guess we have to delete this installation of Debian and install a new installation. So, I did it again. I went to the install page and I configured it so that it would, I said, okay, we want to be only text mode to save as much space as possible. Okay, we run the installer and then it installs graphics again because I don't know why it did that. So, okay, this is probably user error. I've probably misconfigured something in the install file. I go back onto the Debian website. Okay, I've downloaded the wrong ISO file. I have to re-download the ISO file. And okay, I've misconfigured VirtualBox. So I have to reconfigure VirtualBox and then we install it again. And then we finally get a command line, right? There's no graphics here. We're saving as much space as possible, right? And so, great, we can continue, right? But no, because if you had read a little, if you had the foresight to read a little into the book, you would have realized that if you're typing in a bunch of very, very long commands, it's very helpful to have the, copy and paste, right? It's very helpful to be able to paste those commands in your command line. And for some reason, if you have it in only text mode on VirtualBox, you can't copy and paste, right? So I have to delete that one and install the desktop anyway, right? And so, okay, great, we can continue, right? But actually, no, because it turns out that if you had read a little bit into the book, you would have realized that some of the commands just don't work. They just don't work on Debian, and I don't know why. It's probably more user error, but so we actually had to nuke that one anyway and install Ubuntu. So that's great, right? So now I should probably explain a little bit about what we're actually going to do to get this operating system installed, right? We've already got our Linux distribution that we're going to use to create the new Linux distribution. Right? What do we need to do that? Well, first we need to create what's called the file system, right? So Linux has a very specific set of, you can think of it as folders within folders. And those folders have to adhere to a very specific structure, which is up here in the top half. So the big slash represents what we like to call the root directory. You should try to remember that because I'm going to say it a lot. The root directory you can think of as the big folder on your hard drive that contains everything else, right? And so in that root directory, represented by the slash, we have a set of folders that we need to create, a set of very specific directories with very specific purposes. You know, some of them have real words as their names, you know, root, boot. Some of them don't. Some of them just kind of random characters, but they all have very specific purposes, right? We're putting very specific files in them, and that's part one of what we're doing here. Part two is we're actually creating the software that we need to get the operating system running. So the operating system, we need a very specific set of different programs that the book is going to tell us, right, and give us and guide us through installing. We also need the kernel, the Linux kernel, right? We've already talked about that. We need something called a bootloader. We're going to be using grub because programmers name their things strange names. And before that, we're going to have the BIOS and the master boot record, which are a little complicated, but we're not going to have to configure those as much, right? So all we're doing when we're creating our own Linux distribution is we're creating this structure of folders. We are installing all the programs, which the book is going to give us, that we need to compose an operating system. We're installing the Linux kernel, and we're installing the bootloader grub. Did I lose anyone? Okay, great. So days 4 through 5, right? The first thing we did was, it's a little hard to see, but we partitioned up our virtual hard drive on our virtual machine. So we're taking our hard drive, we're cutting it up into little pieces, and each of these pieces we need to put specific things on to make the operating system function. Then we run some, funny-looking commands which just allow us to take advantage of these partitions. We're mounting them in certain places on the hard drive and getting, kind of our tools organized, so to speak. And then lastly, what we're doing is we are downloading all the different packages, we call them, or programs that we need to get Linux from scratch up and running. And so let's go into the specifics of how we actually get a program installed, right? So let's take the program GCC for an example, right? GCC, or the GNU-C compiler. GNU stands for something, it's a funny organization. CC means C compiler, right? C as in the programming language C, and compiler just means it's a program that takes code written in C and turns it into an actual application that you can run. GCC is a very important program for most Linux distributions. You want to have it if you're going to be doing stuff at a low level, right? And so we're gonna go about installing it. I'm going to show you what I did, right? So we have the GCC tar.xz file. You can just think of that as a fancy zip file. And this command we're running to decompress that file, to take all the files out of the zip file and put it into their own folder so that we can mess around and access it, right? And so that spits out a bunch of vomit onto the screen, and it does that for like a minute and a half. And then we get this new command, configure, right? So here we're just configuring all the options that we want to have for GCC, right? Each one of these lines here is a different option, and then we're just running this little program that comes built in with the GCC package to configure it. And then it spits out some more text vomit, and then we run this little tiny command, right? It's called make, right? And make is such a deceptively small word. If the command is 4 characters, you wouldn't expect it to do a lot, right? But it does that. And I couldn't tell you what any of that means. I'm sure there's someone who say, oh, I know, I can look at that and tell you exactly what it's doing. But they can't. And so it does that. It does that for like an hour and a half, right? Okay, great. We have one package installed. And then you realize that, I had said previously that we're doing the bare minimum here. We're installing the bare minimum amount of packages that we need for a Linux distribution, right? To compose our operating system. And it turns out that the bare minimum is actually quite a lot of packages. And if each of these are taking 5 minutes to an hour and a half to install, you can see how that's my whole afternoon. It's gone, right? Lost of time. day 7 through 8, I really started to go insane, right? The Linux, the computer started complaining to me that it has no name, which is a little strange. So this command, there's a chapter that we've hit here, and it's like entering the chroot environment. And, I really stopped understanding most of what was happening at this point, if I'm being honest. The way I kind of understand it is that, we're taking our big root directory that we have on our normal Ubuntu distribution that we installed to install the new Linux, and we're shifting that over to a new root directory on our new partition of our hard drive. I don't know if that made any sense to you. But that's what that command is doing. And then in addition, we also create like I said, the file system, all the folders within folders that we need at this point in order to create our Linux distribution. That's what we've kind of done here at this command. And also, as a side effect, the computer's complaining that it has no name. And then, we go through the text walls and the text walls and the text walls, more just scrolling for an hour and a half. And, the purple and the white starts to blend together at some point. We take a break to install Vim, the best text editor in the world. And, now it's day 9, right? Day 9 it started off horrible. More text, and then more packages, right? You thought we were done with the packages, didn't you? No, they keep going. And these are each taking an hour and a half to install. And so, it's like, and then the names start to make less and less sense. Some of these are real words, like Python's a real word, but MPC, that's not a real word. ATTR, that's not a real word, and you start to kind of go insane after a while, right? It's just text upon text upon text upon text upon text, and these are each taking an hour and a half to install, and it's just horrible. You start to really question your life decisions, right? You start to get very existential making Linux from scratch. It's just the way, I had said this is the bare minimum. This is not if this is the bare minimum, okay, right? We've installed all the programs, right? I entered on day 9, just that I had entered kind of a meditative state, right? Program and program and program and program, and then all of a sudden, it stops, it ends, right? And we have to do something really scary now. We have to install Linux, like the kernel, right? I was supposed to have screenshots here, but they all look like this because I misconfigured my recording software, so I'm gonna take some stock ones from the internet, right? So you can understand kind of what was happening. So when you want to install the Linux kernel, right, remember we've created our file system, our folders within folders. We've created all the programs that we need for our operating system. Now we just need to install the kernel. And when you install the kernel, the book tells you, okay, you want to go into this menu, right? Okay, great. And then you want to configure all these options. Sounds good. And then the book says, and if you misconfigure any of these options and then you run the program, it's going to brick your entire computer and you're going to have to start all over again. And that's not scary at all, is it? That's, 9 days of my life. So, we'll see. I mean, oh no, I have to scroll all the way back through this. I'm sorry. That's what I get for hitting the back arrow. Okay, right. So, I spend like 45 minutes, just because, the book is telling me that I'm going to blow everything up if I do it wrong. Going through each of these menus, right? It's deceptively nice looking, right? After all that purple and white text, right? The blue and the white it's kind of calming, but it's not. Because once you get into the menus, it's like a maze, right? You have to figure out, okay, this is in here, and this is in here, and this is in here. And you're going through each of the menus and the submenus and the submenus and configuring all the options. So it takes me like 45 minutes to find what I need to find and make sure that everything's correct. And I said, okay, I think it's all good. I think I'm not going to brick everything, right? And then I press exit and I forget to save. So I have to do it all over again. So, it's another 45 minutes, right? Where we're going menu and menu, and then menu and menu, right? We're configuring all the options, right? Getting them all, making sure that nothing's checked that's not supposed to be checked, right? I don't want to blow up my computer. And then, okay. I think it'll be okay, I said. And so I pressed the right button to save, right? And then I would have screenshots here, but like I said, I didn't configure it correctly. So you can take my word, it spit out a bunch of scary text, right? And it took like an hour again. But then we did it. Look, this is our Linux distribution. It's not very magnificent, is it? Thinking back, it's kind of weird that I just followed a bunch of instructions and then all of a sudden the purple turned to black and the white text turned to gray text. I'm not sure how we really got here, is what I'm trying to say. But we did it, right? Great. We have our Linux distribution. It doesn't look fancy at all. We log in and it immediately throws 2 errors at me. So something went wrong. But okay. Now it's day 10. It's time to play around. See what we can do in our fancy high-tech new Linux distribution, right? This is 2025. Imagine all the new things we could do. Okay, so first we have to figure out how to access the internet. And unfortunately, the minimum amount of packages does not include curl or wget, which are the things that you need to use HTTPS. So I had to figure out how to use the FTP client and go into GNU and download all the things that you need to get the internet running. And then, it spit out, I started to get flashbacks because it started to spit out more text vomit at me, except this time it's black instead of purple. And then it had me edit this giant configuration file, which is a little scary, right? But that's okay. Eventually, we got a web browser working, right? Isn't that wonderful? It's only text and there's no graphics. But now I can use my homemade Linux distribution to browse r/Linux memes. I mean, 2025, guys. This is amazing. I mean, look at this. I tried to run Doom, and it spit out a bunch of nonsense. So, no, it can't run Doom. But, I mean, we can watch Star Wars in text mode. Isn't that great, guys? Right? This is 9 days. 9 days of my life amounted to this. And, at least we can figure out how to exit Vim. I mean, that was funny to 3 people here. This is great, right? Okay, so maybe the question you're asking right now is, well, gee, August, that sounds like you went through 9 days of your life not really understanding what you were doing, and then you ended up creating something that is functionally kind of useless and that you're never going to use again and also doesn't have graphics, and you're going to, why would you do that? And I'd say, I don't know. I guess I can give kind of 3 morals of the story here, right? The first moral would be plan for everything you do in life to take 4 times as long as you expect. The second moral would be please, please, please appreciate the App Store, right? It's so nice to be able to click one button that says install and then have the program install itself for you. I mean, can you imagine if every time you wanted to install Google Chrome, you had to do all of that nonsense, right? And then the third moral of the story would be if you want to understand anything at the highest level you can possibly understand it, you should try to make it from scratch. Now, I understand at this point more about Linux than I ever wished to understand ever. And, that's debatably a good thing. But as an experience, right, just going through each of the steps, right, figuring out what it really means to install an operating system, and then trying to figure out a way to explain it to all of you, right? Through that experience, I've gained an understanding of how Linux works on the inside, that's deeper than I would have ever gotten had I just, read about it, right? And so, if you're interested in making bread, right? Go home and make bread from scratch if you really want to figure it out. If you're interested in making Linux from scratch, I would not recommend it. But if you really want to, you can. Thank you. I hope I didn't lose anybody, because that was very technical. And we're way under time, like I predicted. Anyone have any questions?
All right. Now that you've completed Linux from scratch, what's your next great achievement going to be? Are you Gentoo or Arc or?
I'm learning assembly, so we're gonna try to C compiler from scratch. We'll see how that goes. Yes. Yeah, but I mean, that'd probably blow up my computer. I would not recommend running a virtual machine in a virtual machine. Yes.
Have you ever considered using dparted with grub to dual boot in Linux?
Dual booting is such a pain. It's like I'm gonna have to repartition my hard drive, attach external storage. It's like I don't want to. Linux is a pain sometimes, and I don't want to have to deal with that in my day-to-day life. I can run Linux when I want to run Linux, but when I'm trying to get my schoolwork done, I'm like, I don't want to have to deal with it. Yes.
At the point where you were installing packages, how much Linux from scratch, the book, the guide,
Yeah.
how much of it was customizable? Did they give you many options?
No.
Oh, it's like a very.
It's very, very, very rigid. You have to do these things. You have to. Right. I'm pretty sure that all of the packages you have, you can't remove any of them. I think it's really the bare minimum.
Follow-up question. Could you have gotten yourself to a point where you could make an ISO or get into a state where you can continue to modify this OS?
Yeah,
And keep iterating on it?
I could have virtual machine make an ISO of the operating system, and then I could theoretically just install more packages, right, that I wanted, right? Like I installed Lynx, the web browser, right? If I want that on my Linux distribution, I could install that and have virtual machine create an ISO. But I mean, I guess at that point you'd have to write an installer, which would do all of the things that I did manually, right? And then it gets really like.
And that's all in the guide.
Right, that's all in the guide, right?
Thank you.
Yes.
What was the size of the
It was like 15 gigs. Yeah. It takes a lot to run a computer, it turns out. Jeremy. I named it better than Arch. Yes. Oh. No. Yes. Yeah, for some of the packages that you end up installing, you need Python to compile them. I don't remember. It was a long time ago, and it was kind of in the middle of like all of the gobbledygook, Yes. It was building it and then realizing that I didn't want to continue afterwards. And then, I still have it in the VM if I want to go and figure out how to do things with it, right? I suppose it would be kind of useful to learn how to do low-level programming, because you really have nothing, right? Just trying to get by like that, especially in the context of assembly, but, Yes.
Have you ever thought of making an ISO and then posting it on the web for others to install a very functional to run Debian-based operating system?
No. I'm not wasting my port forward on that. It's, if you want to do it, follow along with the book. That's all I'll say. Are we all done? Oh, yes. It's online. It's on linuxfromscratch.org, and so you can find it there. I did it on a, well, it's on a virtual machine on the PC I built. So it's very, it's got like an i3 and a 1050. It's not, it's not a lot, you know. Yes. No, the virtual machine allows you to run it self-contained inside of its own. Right. It's not my normal computer's fine right now. Yeah. Yes. I wouldn't, if I was going to, if I wanted the maximum control on my operating system, right, I would much rather just install like a minimal Debian and configure it from there, right? Because, you know, especially afterwards figuring out that I don't even have curl, right? I can't even get things from the internet without using FTP, right? It's like all of the things that are in the base installation, the minimal installation of whatever distribution you want to use, right? You're gonna need those things anyway. So it's like, I'd rather just take something that's already been built and configure it from there. Right? Yes.
I'm wondering, where did you find the time within the school year to make Linux from scratch?
So this was before midterms. This was like right after the end of quarter one, right? And that's a good. I should have been working on my research paper, but
I mean, like, was it just like a straight 9 days, or was it?
it was a straight 9. It was a continuous 9 days. Yes. It was quite unfortunate. Yeah. Are we all done? Great. Thank you so much for coming. Yes. I think sophomore year is hard. Yeah.
Dude, I did this in middle school. I'm like, dude, I feel your PTSD.
I'm a high school junior.
The background.
Dude, I'm a high school senior, so yeah. So I was considering that school based on like it's
Testing. Is Andrew Lim in the room? Testing, testing, testing. So here's yours. I was going to start off by just making sure the microphone was the right volume for you. So if you just want to say, excuse me, a random question, if you just want to say like a random statement for the microphone right now.
Testing, testing. Yep.
So he has your computer and has great.
So you have the notes displayed here? Oh, good.
Yes. Oh, wait. We need to see if the password thing is working. Test it.
Oh, yeah, move the other mouse to this side. Yeah.
Yeah, but
Oh. Then you gotta move this to the other screen. So there's a mouse over here? Yeah, so you just gotta move it over. Yeah, good. How do you move it? You know how to move, select the window and move it?
yeah.
Moving the window to that screen. So because the screen's on that side now. So drag that screen over. Yeah. Yeah, it's extended. So this is actually a second monitor, so we extend it that way. That way the notes shows up here.
And how do I go?
It's just that one of the slides takes some going to use an external website. So then that brings it back. It brings it back
And
to
how am I going to do this back? How am I going to switch it back?
So then when you go back, click on that guy. What is different?
Yeah.
Oh. Oh, because that's a separate window. So now you got to move this guy. And then how do you get back to the notes?
You could just use the side. The side that you made. Instead of just moving back and forth.
Okay. So where's your notes? So when you get back to this screen,
I gotta move it back to here.
okay. So you know how to do that?
No. Oh, no.
And then you go to slide mode.
From the sensitive?
Yeah. Now you got to move the big window over.
So now, and then I can.
Where's the note?
What I did. Not to work. I think I have to read this side, and then I put the backup side right there, so I can just do it, and then.
Okay.
But first, I'm actually just gonna.
Or you can put on that tab on.
I move this back so I can just do it easier.
Oh, instead of going,
Yeah.
yeah, that you don't have to do it. You have the screenshot. Okay, that's good. Okay. You already invite them.
Yeah.
So after this, if I think Jonah and AC are gonna use the same. So you just leave it here. Yeah.
I gotta get things ready now. Oh my god, very funny. You're such a jokester. Oh my god. I hate you, Tanner. Always having to ruin everything. Oh my god. Kenneth, how about you just go to the very, very back?
At 12:15, maybe a couple minutes after, I'll be introducing you, and then I'll give it to you.
Very good. Oh my god. Oh my god.
To let them know? Can you do it?
Yeah,
Okay, let me tell them that you're gonna be doing it. The 20
Test it
minutes.
out. You'll figure out if we can do it.
That's what we signed up for.
Long presentation, man.
I mean, we have it in like 15-minute intervals on here.
There's not time for questions. I think y'all. Oh my god. After my presentation, I'm 30 minutes. That was actually really good.
left of your talk, I'll be holding up a sign in that corner, and then go in 5 and 1 minute. You should be fine.
Can I, the back over there? She holds up this little bit. Oh, you know that.
Okay, so you're gonna ask me stupid questions. Yeah, Lynn? No, it's not.
Hello. Thank you so much for coming to Andrew Lim's presentation on smarter ways to stay safe online by building better passwords. We all know what passwords are, and he's going to give an explanation on how to build better ones, more secure ones than 1, 2, 3, 4, 5.
Okay, welcome everyone. My name is Andrew Lim, and today I'm going to be talking about how to use strong passwords to stay safe online. We all have to use passwords on a daily basis to log into our phones or social media accounts. So it's important we make and maintain strong passwords so those accounts and devices don't get hacked. I'm currently a 7th grader at Nicholas Middle School, and some facts about me are that this year I'll participate in my school's Cyber Patriot program, and then I'm also a U.S. Chess Federation rated pro. Oh. Wait. the slide isn't moving. That's why. Oh, I know. No. That's strange.
There's some. Oh, there it is. Okay. It's because you have to put the mouse over.
Yeah. Okay, so as I was saying, this year I participate in my school's pitcher program, where you have to defend from hackers and make the program safe. And I'm also US Chess Federation rated pro. I don't go to tournaments anymore, but I'm still rated. And I enjoy playing soccer when I'm not doing my homework or in school. So today I'll be talking about what a password even is, and then I'll talk about why we should spend the time to make a strong password. And then once we all understand why we should use a strong password, I'll talk about how to make a strong password and then how to maintain one. So now, what is a password? We all probably know what a password is. It's just a set of characters you have to put in every time you log in. But a password goes deeper than that. A password verifies that you are you, so you can log in. So a password is almost a form of your personal identity. So that's why whenever you give out your password to somebody, it's almost like giving out your personal identity to them. Because now they can get your information and know and pretend to be like you. So now, why should you even spend a few minutes to make a strong password? A strong password will defend your account way more than a weak password. And weak passwords cause many data breaches, computer hijacking, and identity theft. And a weak password will be cracked in a matter of a day. So in a day, all your information can be gone and stolen. So now, you may be wondering how your password can even get hacked. There are a few ways your password can get hacked. The first one is called key locking. The hacker will look at which keys you're pressing and then therefore determine what your password is. The next one is called brute force. To the hacker, your password's encrypted, which means that it's just random characters that's not actually your password. But in brute force, they'll use an algorithm that will decrypt that password into plain text so they can easily get your password. Here are some more ways your password can get hacked. The next one's called worker discovery. Sometimes people write their password on a sticky note or a piece of paper so they don't forget it. But this is very dangerous because then, let's say a friend or family goes over to your workplace or house. Then they see that paper and they'll easily get your password. The next way is called password spraying. The hacker will try commonly used passwords like ABC123 or 123456 in hopes that's your password. Because since those are super common, they have a pretty good chance of logging in. And here are some stats on password-related hacks. 60% of people reuse their passwords for the same account over and over again. You may be wondering why this is even bad. I mean, it is easier to remember, right? This is bad because let's just say you have the same password for your Facebook, Instagram, and Twitter account. That means once your Instagram gets hacked, your Facebook and Twitter account will also get hacked because you have the same password. And then 20 to 30% of people write down their passwords. So this means that 20 to 30% of people are vulnerable to worker discovery at any time. Some more stats are that 25% of people tell their passwords to their coworkers. This means that they're almost giving their identity to someone they may not know very well. This is very bad, especially because that's 25% of people. And then 44% of people have never changed their passwords. So for 1, 3, 5, or even 10 years, they've had the same password. And now that you know why you need a strong password, you need to know what a strong password even is. A strong password will defend your account for at least a year. So the hacker should never be able to hack or log into your account easily. And then a strong password should not be able to be guessed. So if I think of a password on the top of my head, and that's your password, that's clearly not a strong password at all. And it should be unique and common. It should be one of a kind, so no one can ever guess it or easily get it. And it should be long and complicated, with not just letters. It should have letters, numbers, and symbols. So if you're having trouble making a strong password, here are some tips. The first one, to use letters, numbers, and symbols, you can substitute letters for numbers and symbols. For example, L for 1, A for the @ symbol, O for 0, and S for the $sign. These are easy substitutions because they look similar, but they're still numbers and symbols that you put into your password. And then, some letters should be uppercase and some should be lowercase. This makes it harder than just it being all caps or all lowercase. So it should be lowercase, uppercase, or just random. And then, never use any dictionary words. The most common one's always just password. Sure, dictionary words are easy to remember, but they're also easy to guess. And here are some more tips to create a strong password. The next one is to don't just put numbers or alphabet in numerical alphabetical order. This means never using A, B, C, or 1, 2, 3. Just because it's easy to remember doesn't mean it's good. And then your password should have at least 12 characters. That's a minimum right now, but as hackers get better and better with new strategies, it may go up to 14. And then sometimes you can just use a random password generator if you're feeling lazy. When you put in a new password, sometimes Google will say, use this password. And those are always good passwords to put in. But you can also search up a random password generator on a web browser. And then sometimes not even the dictionary words or substitutions will work. This means that sometimes you may need to read a letter or put a random symbol in the middle of the word. So here are some examples of strong passwords. Some of these words are super short, like tree. So how are you ever going to make that 12 characters? You're going to make this 12 characters by putting another word that relates to the original one. So for example, tree turned to tree roots. So you can make it twice as long and way more complicated. And if you're having more trouble putting symbols, you can put parentheses or quotation marks at the start and end. These are easy because they'll link up to each other at the start and end. And then here we can see as we start with the weakest password, which is password, on a password tester. A password tester is where you put your password and it will tell you how long it will take a hacker to crack. And these passwords will get better and better as we apply more of our tips. So this first one starts with the word password, the most obvious, weakest password. It takes 0 seconds for a hacker to crack, which means in 0 seconds, your account is already hacked if you use this password. But then this next password has a number, which is 0, and has the alternating capitals and lowercase. This only makes it very little better, as it's 0.01 seconds still to crack. It's still password. And then this one is a lot better. It has symbols and it's over 12 characters. This makes it 2 hours, and as you can see here, it's a lot better. But you may be wondering, how is this still only 2 hours? You applied all of your tips, or all of my tips. The uppercase and lowercase, at least 12 characters, symbols and numbers. The reason is because this really is still the word password. And hackers know that nowadays. So it's still very weak. So to do this, you're going to have to delete a letter in the word. So now, just by deleting that extra S in pass, you make it 1,000 times better, making it last 492 years. But if your password can last 1 year or over on this password tester, your password should be good enough. And now, sometimes instead of passwords, you can use a passphrase. A passphrase has the same job as a password, which is to protect your account from hackers. But a passphrase is a whole sentence. It doesn't have to be a long, complicated sentence. It can just be 3 to 5 words. But passwords all passphrases are longer than passwords. So they'll be more complicated and protect your account way more than a password. But a downside is that passphrases are longer than passwords. So it may be harder to remember. So now, here are some examples of passphrases. The first one is I love to code all day. This just uses substitutions to get more numbers and symbols. And then same for these two. Cyber defense and E pawn plus 2 squares all use substitutions. But the passphrases would just be one word, no spaces. And then you need to make sure once you've created a strong password, you need to maintain that strong password. Because what's the point in even making a strong password if you're just going to let the hackers get to it? So the best way to maintain them is to use a password manager. A password manager will save all your passwords so you can always go back in and remember them. But it will also keep all your passwords safe from hackers rather than just writing them on a piece of paper or putting them on a file or drive on your computer. And also, to make it so that the hackers don't have a lot of time to guess your password, change your password every 3 months. So every 3 months, if you have a new password and your password lasts at least a year, you'll never get hacked. And then that's it. Thank you all for listening, and any questions? If you put password manager on your phone, you could do it in case you ever forget it. Any others? Excuse me, I didn't catch that. Can you speak louder? How can you think of a phrase to turn to a passphrase? You can just think of something that you always remember. For example, you can say, I like whatever you like, or I love whatever you like. Just anything that's very short. Usually a strong password will always have symbols, but I guess if you make it long enough, maybe over 15 or 16 characters, it could be strong enough. Passwords don't usually use spaces, but if you want to put spaces in there, you can. But good passwords never need spaces. Is that all? I'm starting to put my passwords into a password manager because I'm pretty sure Apple gives you one as a start. So I just got a new phone, so I've been putting my passwords into the password manager. Well, I know this is not good, but I change them every 6 months. But I'm starting to get used to the 3 months thing. I wouldn't say there was a danger in making a password too long, but it may just be hard because you might just type it in wrong a lot, or yeah, that's the only problem. Cyber Patriots is cyber defense, not cyber attacking. No, no. For your phone? Ooh, that's tough, because you have to put in the numbers, huh? Well, never make it your birthday. I know it's common. Or 1, 2, 3, 4. Never good. So just make it, maybe just random numbers will work. but make sure you can remember those numbers. Anyone else? Okay, thank you all for coming and listening to my presentation.
Thank you all so much for coming. Thank you, Andrew. And at 1 o'clock, we'll have another talk in this room. So if you want to come back for that, stay tuned. 1 o'clock.
Oh my God. I was sure that was going to stop cracking up because my camp was right in front of me. It wasn't my fault. No, they added it. They added it. Can you fix me right there?
Or a test. Check, check, check. Check, 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 check. Check, 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 check. Check, 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 check. Check, check, check. Check, check. Check, check, check. Check, check. Check, check, check. Check, check, check. Check, check, check. Is this working?
Oh my God. Roll. There we go. Yeah. You got it perfect. Yeah. Oh my God.
Check, check. Check, check.
I can't believe it.
Don't forget your computer.
The next person is part of our group. They're actually right here. But we're gonna, Jonah's gonna be.
Check, 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 check.
Hello? All right. Hello, my name is Jonah. Sounds good. Hello?
It's being really sticky.
Okay.
It sounds like there's like a little bit of extra, like,
Feedback?
yeah.
Hello?
I don't know if you heard the feedback there. I can hear it.
Hold on. Hello? It sounds a little echoey. Hello? Maybe it's
Every
just in
time you
this.
talk,
Like, what does it sound like?
so you really don't hear it. You know, like in band, how there's like the things that like fall and then it creates like a rain sort of noise. That's what it sounds like.
Does it sound kind of like an echo?
No,
Or.
echo is normal. It's probably just because it's a little bit loud.
Hello? No, I can't hear it.
I don't know what's going on either.
Maybe it's the place you're staying in.
I hope not.
Hello? Hello? Not hearing
Hello?
anything.
I don't know.
I'm definitely.
It's called whacking a microphone around. Testing, testing, testing.
Oh,
Do you
now
hear
that?
that? Yes, that's
Like,
what it's
like
called.
something's being zapped.
Yeah, something like that. Yeah. Alright, got it.
Yeah, I'm hearing it. Hello?
Yeah, so that's the problem. It's
Oh,
never happened before.
hold on. I think I know what it is. Oh. I think it's. Something's making it do it.
Testing. Check, 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 check. Rolling, check, check.
It's something specific.
It is. Yeah, so if I turn the volume down, then it
Hello?
stops. I do not know. It looks like we're like trying to find a remote.
Something there.
There.
Yeah, like around here. I think it's that.
Hold on. You go to the stand and I'll go here. We'll see if it happens.
To the stand? Here?
Yeah, yeah. Test. Check, 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 check.
Hello? I think it's mine. Hello? I hear it.
Yeah, it's more severe on yours. Are we just gonna have to deal with it? Because I don't think we have the time to.
Yeah, I think we just have to deal with it. We should probably.
But then there's a second problem. I have to find another microphone for myself, or I just give you. So, what's your partner's name again?
Aisley.
Aislinn is just. That's okay.
Probably messing around with the. Huh. Oh. Oh, there it is.
Just wanted to do a sound check. Make sure. Okay, so you can just like say a sentence and
Hi, my brother's name is Oliver.
Okay.
Right here?
Okay, so something that I already know about this is that like if you do it too high, then it gives a little bit of feedback. But this is not the kind of feedback I've like dealt with.
Where is ours? Maybe. Tell me if you see it. We need it. There we go. Fixed.
Check, check, check,
That
check,
should
check,
be.
check, 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 check.
Hello?
Yours is good. I'm figuring out these three. Check. Check, 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 check. Hello? Check, 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 check. Check, 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 check. And which color? Did you take green?
Yeah.
Okay. Try it now.
Hello?
Okay.
All right. All right.
So if you want to take your microphone, it might be a couple of minutes just to let everyone filter in and take their seats.
All right.
Hello?
Is it working?
Yes.
Bad idea. Huh? Oh, no. We're not using the mouse.
Okay. So Aisley Morales and Jonah Ibarra. Jonah Ibarra y Aisley Morales. Morales?
Bad idea. Oh, I plan on it.
No, he will. He will do it.
Best way to remove the nerves. Funniest joke. You just did this.
Yabba dabba doo.
In a couple of minutes. I was just going to start right on the dot, just to let people filter in.
That's what Yes, I personally know somebody who was attacked. My niece, my niece was hit with an email phishing scam, which hacked his computer and gave him ransomware, locking up his entire computer. So we had to do a full reset just to get all of his information back. I don't remember.
Okay, so I'll also have signs in the back, so when you have 10 minutes of your talk left, you have 30 minutes. So 10 minutes before it ends, I'll give a reminder just from holding up a sign, same with sign in 1 minute. And I'll just be going up, saying your names, saying what you're going to be talking about, and then I'll hand it off to you two, and you can get started with your presentation.
Can we see that really quick? Yes. Thank you. Where did we first start? Sorry. Thank you. I learned this first from me and my partner looking up online, studying for this specific assignment. All right, let's go.
Hello, and welcome to SCaLE X22. Today we have Jonah Ibarra and Aisley Morales giving you a presentation on scam spotting, including fake messages and phishing and everything of that. So I'll hand it off to you two. Have a good time.
Welcome, everyone. Today we're going to be presenting on how to identify phishing scams to protect yourself from malware, identity theft, and other bad situations online. Hello, my name is Jonah Ibarra, and I'm happy to be here. I'm an 8th grader at Los Nietos Middle School in Whittier. Some of my hobbies include reading and running. I like one more than the other. I'm here today to speak about the dangers of phishing and to reveal how to keep your data safe.
Hello, my name is Aisley Morales, and it's my pleasure to be here. I'm currently a 7th grader at Los Nietos Middle School in Whittier. I am part of the cybersecurity club and can compete in the competitions. I enjoy colder weathers, rain, and painting. I currently have 6 cats and 2 dogs, and I also enjoy going to museums to learn about the past or to just browse around.
For our agenda today, we will define what phishing is and the many shapes it can take. We'll also cover various ways to detect phishing and provide some examples of phishing scams. And then we'll give some statistics that help highlight the importance of avoiding phishing attacks and their impacts. Finally, we'll conclude with some tips that you can use to protect yourself from phishing attacks. Now ask yourselves, what is phishing? Phishing is the practice of hacking into a computer by sending messages that try to trick an individual to take certain actions. The messages contain hidden code that is used to steal information or install malware or viruses onto the computer and other devices. These messages take many forms, and some are not very obvious. Phishing is a type of social engineering attack where hackers use deception to manipulating individuals to give out personal information such as passwords and credit card info. The goal of most phishing attacks are to steal money and gain access to sensitive data or login information. This diagram shows the trajectory of a phishing attack that steals a user's login information via an email. First, the hacker sends a message to the victim, and then the victim clicks on the link or website cited in the message. Then it takes them to a fake website designed to look like a real website, such as the official page for Google. Then the fake website takes their information, sends it back to the hacker, and then it's used on a legitimate website to steal your information and identity.
Phishing scams come in many forms. Here are a few common types of phishing scams. Email phishing, which are attacks done through email. Some examples include external payment fraud, such as PayPal. PayPal is often used to mislead you into taking action on your PayPal account, which is intended to steal your money. Another common email phishing is intercept scams, which target job seekers by advertising fake jobs and bogus interview links. Then we have angler phishing, which targets social media users by pretending to be customer service. The goal of angler phishing attacks is to get personal information of login credentials. Phishing and smishing attacks involve sending messages and making phone calls to lure victims into revealing or downloading malware. Spear phishing targets specific individuals or companies. And lastly, we have whaling attacks, which target organized high-profile individuals such as CEOs and other important people. This is only a small sampling of the types of phishing attacks, but in the end, the goal is to trick you into taking action to steal something from you. Phishing scams have many goals and methods, so of course there are many infamous examples. For instance, the famous spear phishing attack was the Sony data leak where the hackers mass emailed employees pretending to be colleagues. This lost the company $100 million. Or the money award scam. In 2018, the World Cup, a hacker pretended to be a lottery official and tried to get people in Russia to give their personal information to receive a ticket to the 2000 World 18 Cup. Or the infamous whaling attack on Facebook and Google's massive loss. From one email from a foreign country which resulted in the loss of $75 million. Understanding how to detect phishing scams is important so that you will not become a victim like in these examples. So how do we detect phishing scams? Here are a few checks to go through to help detect a phishing scam. After you read the email carefully, look for any poorly made emails and typos. Also look at emails asking for any sorts of sensitive information. For emails, look out for the email address in the from field coming from foreign countries such as Russia.ru, Georgia.ga, or XYZ.xyz. If the email is unknown to you, do not click on it or any links included in the email message. If the caller ID is unknown, do not answer it, especially if you are not expecting it.
Understanding what to look for can be very helpful in situations like this. This is for dissecting a phishing email. Here are 7 things you can check to detect. Using generic greetings like sir or madame indicate the use of a template. Legit emails usually include your name because the people who send them know who they're dealing with and already have your information. Number 2, companies don't request sensitive information through email. It's too easy to hack into. For example, if you were hacked in the past, there's a chance you could have malware already inside of your computer. And events like these allow them to just go into the email and steal information directly from the company, which they don't want. Number 3, official emails do not direct you to links to unfamiliar web pages. It should always direct you to a familiar web page, like their homepage and items of the sort. The links should match the domain name of the company. So if you're getting a message from FedEx, the URL should say from FedEx or something like that. Number 4, companies do not send unsolicited attachments, so never click or download attachments unless you are already expecting one. Like if you're getting bank info or something like that, they would already let you know, oh, hey, we're sending so-and-so pictures. That way you can verify this is you. Number 5, the from email address should match the company name. If you're getting an email and it says from Bill, that should be a red flag already. Because if it says it's from FedEx, it would be from FedEx.com or something of the like. Number 6, hover any links to view the link URL so you can check it and see if it's real. It would have the company name and it would have a little bit of information like, oh, this is a government sanctioned website and something like that. Number 7, this is the easiest way to detect if it's a scam or not. Look for typos or misspellings. Things like this are obvious, but it clearly shows that it's a scam because real companies would go over it hundreds of times to make sure they know it's the easiest way to point out information. Here is a phishing text. Let's look through it and see what you can notice.
Stays internal, so it's accessed within the system by each device. And that's going to be more secure in general. But a LAN doesn't necessarily have to be wired. So it doesn't need Ethernet cables. It doesn't need to be like all one computer. It can be multiple different devices. So really you'll see a wireless LAN or WLAN, you'll see that in a house or here, for example, where you have routers connecting each of the devices and connecting it to the modem. But it is wireless, so you have wireless connection. You don't have to worry about where you are. Now, there are inherent security advantages here, where the devices are connected one-to-one or on a smaller scale. You don't have to worry about as many attacks. It can be secured more easily than if you have a wide-scale system. And yeah, you'll see common examples being schools with administrators having kind of access to all the different computers, all the different systems. All of them are managed. And then office buildings are the same, where you want to keep information secure, locked down, proprietary things you don't want getting out, so you keep it all local, and home Wi-Fi. Now getting into a WAN, a wide area network, you'll see these on more of a global or just a larger scale, where this can be nationwide, where it connects different, it can connect different LANs one to another. So you especially see that in the internet, where it's one home network, you connect to the router. So within that home, it's a local network. But in order to connect that to the internet or just all of the other home networks and the company servers, that'll be a WAN, where it's worldwide or nationwide. So these are going to use things like satellites, where you want wireless connection in large spaces, or there can be fiber optic cables. So you'll see that sometimes in telephones, how it used to be landlines, but now we've moved more towards satellites. And there also are these cables running under the ocean even to connect one continent to another without the use of satellites, which do pose a little bit of a risk and require line of sight, while fiber optic cables that run from one location to another are more expensive, but generally more reliable. It usually is going to have a higher latency, simply because it's a larger space, so signals are going to take a little bit longer to travel, but mostly because it's not going from one device to another. It'll be going from, let's say, your computer to the router to make it wireless, and then to the modem, which then connects from one house to the ISP's kind of servers, and then back to another modem, back to a router, back to the end device. So you have way more connection points that tend to slow it down and cause higher latency. So now now that we have kind of a general idea of the servers, the transmission, the different types of networks, now it's kind of putting it back to you on creating your own server, where it's a lot to consider in creating it, where you have hardware being kind of the first step. Like I've said, a server can be any kind of device. So it can be a Raspberry Pi, where it's a little chip. It can be an old desktop computer, like from an office. I personally have 2 different computers that I got from garage sales that I've been working on turning into servers. So those are maybe like $10 each, and each one can be its own server, each one powerful enough to actually be useful. So that's when you start considering the power of the computer and what you're going to need, the storage, so what kind of device you use, SSD, a hard drive, or whatever you choose. And then network speeds are going to be a limiting factor, where you're determining how fast you can actually connect from one device to another. The next step would be choosing an operating system. So obviously being here, I'm assuming most people are going to be familiar with Linux. So it is going to be a great idea to use Linux because it's going to be versatile. There's a lot of open source softwares, so you're not going to have to rely on paying for anything. You're not going to have to just use a website to set everything up. You have full control, a little bit more security. Just because it's run by you, owned by you, it never really leaves your domain. But Windows is what a lot of people would use just because it's user-friendly, it's more well-known, it's become its own, but it is a little bit more costly because it's proprietary. Then you're going to want to consider network configuration. So assuming your internet service provider allows it, you're going to want to get a static IP so that it's not constantly changing where you have to connect to. It's one constant IP. You can connect there. It stays the same. You don't have to worry about figuring it out each time. And then security. There's a lot of layers to security. I could get into it, but I think we'd be here a whole lot longer if we got into all the steps, all the ports you have to figure out. So we're keeping it simple. In general, there are a lot of main services that you can use, each one with its own different specialty. One of the most common, one that I know a lot of my friends use that I've started using is Plex. So that's very well known. It's a media streaming server. You download a movie or a video, however you happen to get that content. You're going to take it, download it, upload it onto your own computer, and then anything connected on that home network can access the movies, access the shows, and watch them for free without having to deal with a streaming service. So alternatives are Jellyfin and Emby. There are a ton of other ones. And then for network attached storage, that's going to be a different type of server. There are obviously the main ones, Unraid, Open Media Vault, typically more well known. And then the deeper down the rabbit hole you go into what you want specifically, you can start figuring out other services that provide it. And then for file backups, which are going to be in case you need an alternative storage device. So if you have one computer running all of the files, all of the data, and that computer crashes or breaks or there's a water leak and it destroys the computer, you lose all that information. So a file backup, basically just a backup drive on a separate computer, separate location. There are their own services for those, different open source softwares, all essentially the same but with different features. So yeah, thank you guys for listening. Do you guys have any questions about what I've talked over? Yeah. Yeah, a lot of the sources that I mentioned are going to have their own instruction manuals. So if you want to use any of them, yeah, go ahead, take a picture. Each one is going to have its own setup information if you choose to use it. I also honestly recommend Reddit because it's going to be a lot of people that have done it themselves, can give advice that maybe the user manuals might not provide. So, yeah. Anything else? Yeah. Yeah. Obviously, you can rent out a server. That's always an option. It's going to be fairly simple. It's just going to cost more. So you obviously can. Might be more powerful. But if you really care about security or cost effectiveness, you can have your own computer running off of just the electricity costs themselves which are going to be very cheap if you're running a Raspberry Pi as your server, or, an old jailbroken laptop. It's going to be a lot more cost effective than renting out a server. Yeah. So a VPN is going to be great for security, obviously. I would personally use just more of a local network. So rather than using a VPN to kind of make it more secure, if you just keep it local, just kind of a home network is going to be more secure. But if you're talking web server, then that's a little bit different. I'm not too certain about. But. Any other questions? All right. Oh, yeah. I haven't personally, no. Mm-hmm. Okay, yeah. Mm-hmm. Nice. So what's the name of that one? All right. Yeah, I'll make sure to keep that in mind. Nice. All right. Well, if we don't have any more questions, then I'm going to say thank you guys very much. Yeah, thank you. Go for it. Yeah.
Check, check. Testing 1, 2. 1, 2. That's good. Okay. That's good. Sounds good.
You know, whenever you're ready to pick it up. Yeah. Okay, so you're good. You're projecting.
Check, 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 check.
I'm feeling good. No, I'm here. I feel good.
Yeah.
Not right now.
Okay, good.
Although I could use some more water. So maybe
Oh, right here. Here you go.
Oh, perfect.
Yeah. You got water there. And then, so your start time is 3:15.
3:15. Do what? Oh, yeah, to do present. Oh, I messed it up.
Hello and welcome to SCaLE X22. Today we have Alex Morale giving a presentation on building community and social capital on the internet. Thank you, Alex, for being here. Take it away.
Thank you, everyone. Welcome to my one second presentation. This is my first presentation, so I'm very excited to talk about this. It's a very important topic to me. And so yeah, let's begin. Why build a community online? Well, there are many reasons. An online community can mean a group of best friends. It can mean authentic self-expression. It can mean a horizon of endless possibilities to achieve and coordinate goals with a world of others. In a globalized world where local social outlets have declined and mass entertainment has gone online and mainly interactive, it makes sense that the demand for an online community would rise exponentially. Why do I do it? That's what my dad always asks me. Why do I spend like countless hours and ceaseless thought and energy into building a community? Well, it's for a few reasons. I do it because I see the demand, and also because it's fun. I lead a gaming community. But also, I see the true potential of the online community, the true scalability and power of a community built and led with just a few truths in mind. There are so many digital leaders today, especially in the gaming scene that I see, and yet so many of them have such a limited view and limited scope as to the capability of their communities. And they don't collaborate with each other to share knowledge and really improve the technique of leadership, which makes others like new community leaders have to start from scratch. But online communities are not just for gamers. They're for everything. And that brings us to today's main point. The role of a leader within an online community has become extremely important and accessible in everyday life. Despite the rising popularity, there is a lack of knowledge and understanding of the mechanics behind an online community. So many people don't know the why of how it works and really the behind the scenes of the whole thing. However, there are key principles and skill necessary to start a community which can be utilized to aid new leaders and grow communities. And that's what we're going to be talking about today. And so, let's start with the platform. When choosing a platform, there's some, wait a minute, one sec. There you go, my bad. When choosing a platform, there's some key factors that you have to keep in mind. And it's a very important choice. It's, where your audience is going to be, it's how you're going to build it. It really, describes the limit to your community. Well, firstly, it's picking one that fits your members. Who are the people you want in your community? Who's your community for? And so what platform do they already use? There's nothing more frustrating when I'm going to recruit into my community, right? And it's like they're all excited about it, they love to do it, and then, oh, they don't have Discord. Oh. And so, yeah, it's very important. And to find the right platform the right platform for your audience, there's a few ways you can do it. You can look at other communities that are similar to yours and see what they use. Of course, you can also ask around, and you can also look at content produced by your audience, and what communities do they plug into their socials, into the promotions and all that. And so using those methods, it's very important. Using those methods is very important to choosing the right platform. But besides the audience, there's more to a platform. It has embedded features in the software that allows the community to be organized and expand. Organization tools like channels and roles allow for the organization of a community to grow in complexity and be scalable as the community grows in size. Although most platforms do have direct messaging, having it be extremely accessible for the leadership to DM any member of the community becomes extremely important with the greater size, as will be discussed even further. Of course, moderation capabilities are obviously very important, and the benefits of being anonymous depends on the type of community that you're building. Gosh, okay. A very underrated feature of communities that I think are very important is the ability to collect the data. Robust search functions, or perhaps, having all the messages stored in the server or in the community. It is so useful in order to learn from the community's history, just looking back on it, but also in order to collect data. And the ability to collect numbers, such as recruits, such as attendees for your events, and all that kind of stuff. And so having those features is very important. Now, once you choose a platform, you want to go and make a digital space on it for your community. In this presentation, I'll just walk through how that works on Discord as an example of making that digital space that your community can inhabit. For any platform, you'll just go to the website. Go ahead and sign in, log in, or make an account if you haven't already, and after that, you'll go ahead and make a server. On Discord, it's making a server, but for other communities, it may be different. After you go ahead and do that, you want to go ahead and, when you're going to make a server, on Discord specifically, you want to go ahead and choose a custom template and choose the size for a community and club. After that, you want to go, and once it's made with some customizability options, you want to go ahead and make the channels and roles of the community. Channels are how you organize the communications of the community, and having category permissions also allows the organization of the community, the different roles and types of members. It allows for scalability, and it's very important for organizing it. As for role permissions, you want to keep in mind that not to give admin to roles since it's not necessary, and also you got to make sure to give them roles to see message history. It's very annoying if you don't. A lot of complaints. Now, while you're choosing a platform, making a server, you want to know the mechanics of your community, which will operate behind the scenes and not only grow your community, but also help in decision-making as it grows. So, let's talk about the mechanics, shall we? The first mechanic of the community is recruitment. Sort of obvious. Recruitment. It's inviting members not in your community, but in your audience, and it's inviting them to the community and making them a member. It directly increases the size of the community, and having consistent recruitment is very ideal because it allows, not only does it secure the community's future, but also allows for forward-thinking leadership, knowing that there's a constant income of people and just like recruits coming in, keeping the server active and participating. When thinking about recruitment, you want to think about the place you are recruiting, which you derive that information from the people you are recruiting. Who are these people? What do they do? That's going to tell you where they're going to be. And by place, we mean digital places as well, especially if it's an online community. And as such, the type of people you're recruiting also informs you the best process as to how you want to invite them to your community. These will depend variously on what kind of community you're building. However, the universal skills for all recruitment will benefit from confidence, patience, and having initiative, making sure to reach out to those people. Each of these mechanics I associate with a class or rank within the community. I call them ranks because most gaming communities have it like military style. That's why they're called ranks. But they can apply for non-military communities, obviously. For recruitment, I associate most closely with the lower ranks, which act as the newer members of the community. The newer members of the community, they enjoy the community and benefit from it, proportionate to their participation in it. And yeah, it's important to always have a stream of new low ranks and new members into the community. for the reasons I just specified. Moving on from recruitment, the second mechanic is communication. And by this, I mean directly via DMs. Of course, communication happens within the digital space, but with direct messaging, it creates individual personal relationships which provide the social infrastructure of the community. Communication is the glue of the community. It bonds and connects the community together, keeping it centered and together against disintegration, which after a certain size becomes a real threat to community to a certain. And so to that extent, communication is vital for communities of a large size. Inactivity is a fatal lack of participation for a community, and communication is the solution against it. You know, people get busy, people forget, some people don't have their notifications turned on for your server, happens all the time, and communication totally resolves this issue, because by directly messaging your members, by reaching out to them, you keep the community in their minds, and even in that instance they're not available, they might become available in a week, in a month, maybe even a year, but it is in their mind. These communications not only increase the activity of the server and therefore your participation, but it's also important to build independent relationships with them, personal individual relations. As I was saying before, it provides the social infrastructure. Social infrastructure is the collective individual connections which form the basis of the community, and the strength of this and the distribution of this is the design of the community. And as such, it is very important to communicate. And yes. Now regarding communication, the best advice is to just make sure to communicate with semi-regularly with inactive people. You never know when they're going to become interested again, or when they're going to be able to participate again, where they're going to be not busy anymore. And yeah. Although communication involves all the ranks and people of the community, I've associated with high ranks in particular because high ranks are leaders, and leaders are made by communication. Leadership itself involves a ton of communication, and as the team of leadership expands with the complexity and tasks of the community, it becomes absolutely necessary to communicate with each other with increasing amounts. High ranks in a community are the only members which have an ongoing responsibility to the community, besides following the rules, and because of that, it is ultimately a position of service. In exchange for this service, high ranks are granted help with decision-making and some authority within the community. Regarding the amount of high ranks, it's important to only scale them up to the complexity and different tasks of the community. That is because they require communication, sometimes training, requires effort to keep them around. As such, you don't want to have high ranks that don't do anything, only proportioned to the complexity of the community. After communication, it is the third and final mechanic, the event. In one sense, an event is the goal of a community. And that's because participation is currency, and the effectiveness and power of a community is directly associated with the participation of its members. By concentrating the participation of these members in time and digital space, the community is able to express itself, fulfill its purpose, and do its service to its members. The event also becomes a sort of microcosm, a miniature model of the entire community. The relations between the event host and the attendees mimics the relations between the leaders and the members of the community. And obviously, tons of communication revolves around events, and additionally, recruitment as well revolves around events. I myself always recruit during events, and it's just the most efficient way to do it. As for the rank associated with the events, I've associated them with the middle ranks, which are full members of the community, which are often reliable, and which are often, and which have usually more skill and just been in the community for a much longer time than low ranks and new members. This is because, why did, one more thing regarding the events. When you're timing events, you want to figure out the frequency, the duration of the events, and also just like the type of events. You can't really, it's highly variable depending on your community, and because of that, and because of that, there's not much more to say about it. However, its importance cannot be understated, and as such, I've associated the events with the middle ranks because the events, at least in my community, is how lower ranks become middle ranks. Now, each of these three mechanics work together to form the community. They're all interconnected, they all relate, and they all change each other in some way. Recruitment and communication increase the event attendance. Events increase recruitment, like I just stated, which are kept integrated and together with the community thanks to communication. And communication, of course, binds it all together, allows for the community to be scalable. Even the numbers of these three ranks, those can all be directly impacted by your amount of each activity. If you want more low ranks, recruit more. If you want more middle ranks, you have to host more events, and so on and so forth. And even the amount of these ranks give you the capability in order to communicate event and recruitment, and determines the amount and the capacity for that. Now, these fundamentals are great and all, but leadership isn't only about knowing the theory of behind the scenes of how a community works. It's about actually having the skills to be a leader. These skills of leadership can be used for three purposes, each building off of one another and in their own ways of developing and being gained. Firstly, there's skills in building social capital, making friends, and building relationships, obviously fundamental to leadership. These skills for gaining social capital include basic conversational skills such as likability and agreeability, which is important to get rid of friction and helps build connections. An outgoing initiative, it is extremely important in order to build social capital because you cannot wait for people to come to you. You have to reach out in order to build something. And that includes social capital, includes building connections. Empathy is another important skill, as empathy enables understanding. In order to gain those skills of conversational skills, initiative, being empathetic, reading lots of books because of linguistic mastery for conversation, and also just practicing and building confidence. Now, becoming a leader in an already established community, it builds all the social capital skills, but it adds a few additions as well. Now, this is by becoming a leader, I'm not talking about building your own community yet. I'm talking about being in a community, wanting to have a leadership role within that community. In order to do that, it requires a lot of commitment. It requires time. It requires showing up, showing that you care, showing that that you participate, and that also that you know what you're doing, and that you're competent as well. This obviously requires time to build the social capital within the community, and so because of that, it requires lots of patience additionally. Now, to develop this competence, patience, and commitment, it's going to require a lot of time and thought. And now, this is easy if you're passionate about it, but if you're not, then you probably shouldn't be becoming a leader of that particular community. Just because it's going to be hard to find. Finally, the last sort of like digital leadership skills, it's building social infrastructure. And by this I mean either starting a community or already leading a community and then expanding it to a scale where it requires a reform of the organization, where it has to change in order to build those connections and to sustain that size. This activity is the most difficult, and it requires relentless determination to be successful. It requires a keen inquisitiveness in order to innovate. Innovation is highly required in building social infrastructure. And also requires creative thinking to solve the numerous problems that you receive. All of these abilities require a healthy dose of inspiration and ambition. And although it is more difficult, I find it a lot more rewarding than just leading alone, because when you're building a community or when you're expanding it where it has to be built, it really gives you a distinct character, as you are the designer, and the design is directly representative of you, and it's unique. Now, these skills are very important, and you can't lead without them. But if that's the case, why even have the theory behind the mechanics and other similar conclusions? Like, why even have the mechanics thing that I just talked about? Well, there's a few reasons. For one, what I call theory is just the organized skills and knowledge. Theory can act as a tool to figure out what to do, and also as a guideline in order to design a community that you're building. It can be a jumpstart for expertise without needing years of experience in the beginning. And it also provides a language for discussing other communities and comparing and contrasting operations and functions between them, comparing how they all are different and compare to each other. Now, of course, the organized knowledge and skills of community leadership is very low at the moment. That's because, as I was saying in the beginning, people don't really share. People don't teach others. However, the future possibilities of these are really endless. If expanded, for example, my concepts of mechanics can be especially useful for visualizing new scales and perhaps make common models of development between different communities, similar to the demographic transition model. I've actually used numerical conclusions a few times. They're not as accurate because there's not too much data yet, but conclusions regarding the minimum amount of recruits needed and also the probability of success regarding communication, perhaps the impact of friction and gravity. These are all potential developments if more data and numbers were collected for a theory. And of course, like I said, having a common language to discuss the causes and effects of different reforms would be very useful for comparing and contrasting different communities and then deciding which forms to develop, how to develop. And regarding notes on creating your own theory, since it is important to learn from your mistakes and not be constantly repeating yourself, and to avoid like patterns of failure and all that, even if you're not sharing with others, there are a few notes to be taken. One, data collection. You have to collect, you gotta have some numbers, because you never know when you'll want them, and you'll really regret not having them. For me, I collect data on recruits, event numbers, and weekly attendees, different people per week. The major one that you have to have is some sort of number to quantify participation, since participation is the currency of community. And without that number, you kind of don't know if you're making progress or growing as a community, or if you're like just remaining stagnant. So that's a very important number to have. Other things to collect is, and to really like document, include reforms and events. Events are just great to look back on and to remember. They also contain a lot of information. But additionally, reforms are obviously very impactful since they do change the organization and perhaps the social infrastructure of the community. The other thing to keep in mind with theory is that it gets more useful as you grow in scale, not only as you gain experience and so you know what is actually true and what isn't, but also as you gain more data, and so the individual factor of certain individuals becomes less impactful, and the guiding principles and the guiding principles of community leadership as a whole becomes more apparent. Which brings us back to our main point, which is digital leadership is important. Online communities are becoming more popular and successful every year, every day, every week, you know. And you have to consider, and considerations of making a platform include, not making a platform, considerations and making community include the platform, include organization, include the mechanics, the design of the community, how the communication is designed, the ranking system, how easy it is to gain one rank over the other, how difficult it is in regards to all that sort of stuff, and just the mechanics behind it and the theory behind it. Keeping track of data and using theory can aid new leaders and grow communities, and that is my talk for today. Thank you all for attending. We're open. Yeah, we are open for questions now, and if we don't answer questions already, you can email me. Yes? Going to people directly. But also, the thing is with my community is that it is a gaming one, so like, we'd only recruit in the games that we already play in. But yeah, the best technique is, at least for that, is it's the place. Like, we know that we know that they're part of our audience since they're in the game that we play. And then from that, the best process is just like reaching out and asking directly. Of course, you're not going to get everyone. Actual games. Well, our games are usually multiplayer. They have a lot in common with like MMOs. So it doesn't really work too well with single player or games that are more like party styles where it's like you have to like join a party to do that. And so, yeah, in the game, we go up to people and ask, hey, if you want to join. A lot of times, because they're similar to MMOs, they have their own like guild or faction systems, and the ability to collaborate and have others help you in a game is also an incentive to join, since like playing games is more fun with people. You get bored if you don't, and you also get, and it's also like a lot of people in our community have resources that they give to others, like new members of the community, or they can, you know, teach new skills in the game. Yeah. I don't do that at the moment for my recruitment, but like looking at the results, like it does help. You know, it does help to have that other sphere of recruitment. So yeah, I definitely recommend that. Like it depends on the type of community it is. Because like if you have the capability to just go up to people directly and have it be convenient, they're already doing the thing that, you know, distinguishes them as part of the audience, well, of course they're going to, you know, make sense. But otherwise, yeah, Twitch streaming makes a lot of sense, and so does YouTube. What is, okay, yeah, yes. How do you handle moderation? As you're at the very start, you can do the moderation. It depends on the size of the community. A lot of it is having that like culture already, where it's like either the people that started in the community already, you know, you don't have to worry about that pretty much. And then from there, when people go in, they sort of like assume, okay, that's the culture and all that. And when they don't, it's only like one person that's an issue pretty much. But also, another important thing is, you know, at least for Discord, it's like invite only. And so you're sort of like either you already have contacted that person beforehand, so you know where they're coming from, or you have part of your team already knows that person. So in that sense, like knowing who's coming into the community already, that helps a lot as well. Yes, role system for sure. Yeah. Yeah, no, it's definitely like it's definitely like difficult sometimes to draw a line where it's like, do you want to moderate against this or let it happen, or do you want to warn? It is sort of like a difficult thing, and I think that's why, you know, because you're always going to have those difficulties no matter what, and like of course, it's better when you handle it, but to a certain scale, you have to have others, and they have their own personalities and ways of doing it. It becomes not like equal in terms of like the same standards applied. So yeah, but in that case, the best way to handle it is just to have that culture at the very start and not let it like develop. And so from there, you can sort of like get people assuming and stuff. And also, if people like respect you, you know, they kind of like fear you sometimes, so it's fine. All right, is that all the questions for today? Thank you all for coming. Thank you so much. Hope you all enjoyed this session.
Be sure to come back at 4:15 for Alana Wu's presentation on virtual reality and helping people on the autism spectrum. Check. Check, 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 check. Check, check, check. Okay. So on here, you just say a random sentence, and I'll give you the thumbs up to say it, and I'll just adjust the volume and make sure that it gets better. Hi, my name is Alana Wu, and I'm talking right now. Is that good? Yeah. Hello. Hey guys, what's up? How are you? Hello. Set. Yeah. Okay. Yeah. Do you know what the Wi-Fi is for the room? Yeah. Okay. Interesting. Yeah. I'll try to direct you to someone who does know, because literally I've been to every talk in this room today, and none of the times I've been working there. So you might just want to connect it to your hotspot on your phone. Okay. I don't know if I have MSOS on that right now. You can just try. Yeah. Should be fine. Okay, that's fine. Works. Thank you so much. Yeah. So as long as you can present it. Yeah. Oh. Oh, got it. Okay, give me a second, and I'll do this.
sense. It's not like directly just autism. So it's kind of just like in a broader sense, just like an integration of like musical therapy and technology.
Okay. I'll just say like using virtual reality to enhance anxiety management because I know for a fact that I cannot say all that
Okay.
without messing up 5 times.
Yeah, that's fine. No worries. No? I don't know where she went. So thank you all for being here. This is welcome to the next generation class. So this is our final presentation of the day on the PM track. So we want to welcome Alana and give her a round of applause.
Thank you so much. So my name is Alana Wu. I'm a junior at Orange County School of the Arts. And then today I'm going to be talking about like integrating musical therapy with technology, and then my application of that with Euphony Echo, which is my program. So first of all, like my concept was generally based on the idea of musical therapy, specifically to alleviate like stage fright. And as a specialized field, musical therapy, when integrated with singing, can become a catalyst for personal growth and emotional growth. And then your brain, basically, it's hardwired to distinguish music from different sounds. Like it can recognize rhythm, repetition, notes, and tunes. And it's essentially because music is mathematical in a sense, and it's architectural, and your brain has to do computing to really recognize it. Like for example, music follows a framework, like if time signatures, things like that. Like a waltz has a 3/4 time, giving it a distinct like 1 2 3 1 2 3 pattern. And then notes are also organized in using frequency through hertz. Like for instance, a commonly known one is the A above middle C is 440 hertz, which I actually used for testing of my program. And then also intervals between notes, such as like octaves, fifths, they're mathematically consistent and create like different harmonious relationships. And then in a more technical sense, when sound waves actually enter your eardrum into your cochlea, there are cells that release chemical neurotransmitters that activate the auditory nerve. And then that basically sends these electrical currents through your auditory cortex in your temporal lobe of your brain, which then goes to your motor regions like your basal ganglia, your hippocampus, and then your amygdala. And these are your body motor systems, so that's why you can like kind of like groove to a beat or like tap your foot along with some music. And then also another part of your brain, which is the limbic system, that kind of regulates your emotions, your motivation, and your memory. that helps connects melodies and harmonies to emotions, which makes music feel expressive to each individual, like personally. And then in a general sense, singing also like has certain techniques such as like inhaling, exhaling, which like obviously like it's very beneficial for you, like yoga breathing, things like that, which help you relax. So just generally, music is just a great way of like communication and expression. So these are a few types of existing musical therapy. First one is karaoke, which is a therapeutical karaoke experience where participants process emotions through music with a therapist's guidance. But there are some limitations which include like its geographical settings and then group settings that could possibly hinder personal growth and disclosure. And then we have songbirds, which is a emotional exploration through nonverbal communication of music. And while it's effective, it does limit engagement due to lack of home-based options. And then lastly, I have Tang et al.'s study, which highlights musical therapy and musical like medicine efficacy in reducing depressive symptoms, but it lacks personalized treatment and has methodological inconsistencies. So I touched a little bit about this earlier, but basically musical therapy has great potential in helping individuals with emotional regulation, communication, and mental health, especially for people with like who suffer from anxiety, depression, or maybe like neurological disorders. However, there are these certain challenges, such as, first of all, limited accessibility. Like who really knows about musical therapy, right? And also professional musical therapists are not widely available, especially in rural or lower income areas. And then many people who could benefit the most from these programs probably don't have access to trained professionals. And then secondly, like musical therapy sessions can be expensive because they often require specialized training, one-on-one guidance. And then also like insurance cover is inconsistent, which makes it difficult to afford long-term therapy for certain individuals. And although virtual and AI assisted therapy is growing, most musical therapy still relies on in-person sessions, and there's untapped potential for apps, virtual reality, and machine learning to create more personalized and accessible experiences, which I will get into in just the next slide, I think. And then many people also still just see music as entertainment, which it is, obviously, but it can be used as a legitimate therapeutic tool, though it's very personalized for each individual. And this perception limits its acceptance in medical and educational settings. And then lastly, not all individuals respond the same to musical therapy. Finding the right type of music structure and delivery for each person can be challenging. And more research is needed to understand how different demographics and neurological conditions respond to music-based interventions. Okay, so I want to get into like how we can integrate technology with music, and these are some benefits of it. So first of all, AI and machine learning for adaptive therapy. AI models can analyze like vocal tone, lyrics, musical choice to like gauge your emotional state. And then machine learning also can adjust like the tempo, genre, melody based on the biofeedback. And then VR and augmented reality settings just create a more immersive experience and then create customizable spaces that enhance engagement and relaxation. And also more interactive like motor skill development. And then biofeedback and neurofeedback integration can track users' responses to music, like you're monitoring your heart rate, adjusting rhythms and frequencies accordingly. And then there is possibility for like wearable devices to provide tactile sensations aligned with musical therapy goals. And then we have data science for therapeutic insights, which identifies correlations between music and music therapy sessions and emotional cognitive improvements. And then AI-driven apps enable therapy in non-clinical settings and seamlessly integrate between mobile, tablet, and VR applications. So I want to get into like my application, my attempt at it with the Euphony Echo, which currently is like a novel vocal training program that is like designed to potentially tap more into musical therapy goals. So I'm going to read through the abstract for my paper right now, and then I'll get into more specifics. Wait, I can't see. Okay, performance anxiety, commonly known as stage fright, poses significant challenges for individuals aiming to enhance their singing abilities and stage presence. To address this issue, we have developed a virtual reality simulation that explores a concert environment, offering users a safe and controlled space to practice and improve their performance skills. The program integrates a vocal engine for real-time pitch analysis, an immersive environment both on-stage and off-stage settings, and a diverse song library with synchronized lyrics. Key challenges included accurate pitch detections, which were addressed by broadening the range of permissible pitch variations, and then enhancing user immersion through detailed stage design and dynamic movements. During experimentations, users engaged with VR simulation across various scenarios, receiving immediate feedback to refine their vocal skills. Results indicated significant improvement in users' confidence and performance quality. This innovative approach offers an accessible and effective solution for individuals seeking to overcome stage fright and develop their musical talents in a supportive virtual setting. So, breaking it down, this is how it works, technically. So, basically, the user journey will start backstage in a kind of real environment where they can, prepare, calm their nerves, just get ready. And then they can select their artist and their song, which will pop up with their difficulty levels, their past scores, and then upon clicking the start button, the program will transition them into the main stage scene, which initiates their performance. So once they're on their main scene, users unleash their vocal prowess as the vocal engine will analyze their real-time pitch. And this dynamics allows users to enjoy singing while also receive valuable feedback. And then users can adjust pitch-based parameters in the VR environment, which adds a layer of personalization to their virtual performances. Once they finish their performance, we have a result of their score, just all the information where they can either go back to the backstage or just quit the application. So I built the program with C# and then Unity, C# through VS Code. And then it's built specifically for the Oculus Quest Pro 2. So I have a few samples of the code. This first one is just kind of the pitch detection. So basically, the start function will initialize by ensuring that the microphone input is really inputting sound, and then it analyzes where it falls within a certain spectrum, the mic spectrum. And then the song source finds where and what the audio source is to inspect how the pitches if the song spectrum relates with mic spectrum. And then the application obtains the spectrum data for both the microphone and the songs using the FFT window Blackman-Harris function, which is a way of periodically analyzing and transforming signals into frequencies to make inputted audio more accurate. And then the recorded pitches from both audio sources are stored in their respective history data structured for further observation. When they're recorded, the pitches are then averaged to help further avoid being influenced by any anomalies present in the reading. And after all the pre-processing steps are complete, the pitches are then compared to see whether or not the user is deviating from the source or remaining within a certain threshold. So essentially, it just periodically analyzes and transforms signals into frequencies to make the input audio more accurate and compares the input of the users with the pitches of the song. And then this little piece is just saying upon entering this stage scene, the scene's gonna check what song was chosen and then follows that up by filling out all the UI elements that come along with the song. Depending on the difficulty of the song, the currently invisible, as you enter it'll be invisible, but they'll update the end panel with the difficulty and all the information, and then throughout the performance, live updates will be added regarding the score. And then the system notifies both the microphone and the song sources to begin their task once everything has been properly initialized. And this is the last little piece of code. So basically, I used Unity Scriptable's object system, which is a way to create serialized data that's easily slotted into dynamic situations. And this helped support the large variety of songs that I implemented. And the application uses this by defining two scriptable objects and a color that references, we'll see in a second, neon lighting. And then we have the song scriptable object, which has the artist name, the song, and the audio clips for both the instrumental and lyrical version, as well as the difficulty drop down so that you can specify like the difficulty in like relative to other songs. And then lastly, the lyrical field is just basically like once you're on stage, you'll see this kind of karaoke-like. You just try to pace it to with like the song so it works like karaoke. So let me give you a quick demo of the game. Okay, wait, I'll just do this. Okay, so this is the Unity. So well, it's gonna be a little hard to navigate. So this is the backstage scene where it's just kind of like basic things you'll see, like instruments, clothing racks, like changing your outfit, just kind of a place to relax. It's very basic, very plain, just to give like a more real environment. And then once the user's ready, they can choose their artist here. Right now it's kind of just like very typical karaoke, like pop artists and pop songs. So let me run it real quick. So like if I choose Bruno Mars, is that Bruno Mars? It'll start playing, right? Just so you can like kind of preview it, and you can choose whether you want instrumental version, or I can turn off the music right now. It'll give you the difficulty of the song, your past scores. Right now I don't have any past scores, so this is the default. And then once you start, you're gonna be transported over. Oh, I did not start it, oops. So, Bruno. Oh, okay. Sorry, this is the main stage scene. Let's take us over there right now. Sorry, give me 1 second. Okay, here it is. So I have the end panel up right now, but essentially when you actually play it, it won't be there, and then your song will kind of flow up. Let me see if I can turn this off for us right now. UI. Canvas. Okay, here it is. There you go. So in the main stage scene, we just have a typical like stadium type setting concert. On the left side, you'll have this bar that shows your progress at the song and the time. These are the lyrics. Right now, it's just California Girls as the default, but when you actually switch into it, it'll be the correct lyrics. And they just kind of go up while you're singing as like help for you. And then while you're singing, you have this scoring system, which numbers and then letters up to a score of S, which will automatically give you live feedback based on your pitch variations. So yeah, that's how the game works. That's what it looks like. And then we did a few experiments with it. The first one being to evaluate the effectiveness of VR-based singing therapy program to reduce stage fright, improve singing accuracy, and enhance user engagement. And these are the values that you can see here. But basically to evaluate, we had 10 participants with mild to moderate stage fright divided into an experimental group and a control group. And the experimental groups practiced singing with the VR environment, utilizing the vocal engine for pitch feedback and immersive stage dynamics and diverse song options. Then the control group used traditional karaoke setup. So they gave pre and post test assessments measuring stage fright, singing accuracy, and user engagement. And then we analyzed the data here. So basically I broke it down to the highest value, lowest value, the median, means, just so we can see a better picture. And you can see there's a significant reduction in stage fright and increased singing accuracy among experimental groups, which highlights the effectiveness of VR therapy. And the biggest impact comes from real-time feedback and immersive elements. And some control participants showed minimal engagement and improvement, which kind of emphasize the value of VR interaction and personalization. So yeah, these findings help us validate the hypothesis and encourage further studies. And then our second experiment was to assess user satisfaction with a VR-based singing accuracy to measure the score on 5 different elements. So we had 10 participants between ages 18 to 40. After a 30-minute session exploring features like pitch feedback, the environment, and song options, we had them complete a survey rating 5 elements, which is the ease of use, the immersion, feedback, effectiveness, song variety, and overall enjoyment on a 1 to 10 scale, 10 being the highest. So once again, breaking it down, highest score, lowest score, median, and mean. The immersion and overall enjoyment received the highest ratings, which highlight the VR program's engagement nature. And then surprisingly, feedback effectiveness scored slightly lower, potentially due to new users finding pitch analysis less intuitive. And then the song variety had the lowest minimum which kind of suggests a need to expand content, because as you saw earlier, it's just kind of the basic songs. So yeah, I will hope to address these in the future, which I will talk about now. Future development, I want to deepen Euphony Echo's focus on musical therapy by introducing features that enhance both emotional and physical well-being, such as rhythm games that would help users' engagement with structured patterns, improving their sense of timing and control, which are skills that are often linked to emotional regulation. Guided exercises like vocal warm-up breathing exercises to promote relaxation and reduce anxiety. Since controlled breathing is a key technique in both music therapy and mindful practices. And then as we saw earlier with the feedback, expanding the song catalog can offer users more opportunities to connect with the music that resonates with them personally. Because as I said before, music is a very personal experience due to the connections that your brain makes with your past experiences. So a larger array of song catalog. And then lastly, a larger range of environments, because currently as you saw, we only have the stadium right now. I think that it would be really interesting to have different environments, such as a more secluded jazz band, or in a jazz environment, right? It's just to everyone's personal preferences. And then maybe someone wants to put themselves out there, they can sing on the streets of New York or something like that. Just different variations for people to explore. And then that would foster deeper connections between themselves and the music. So in conclusion, Euphony Echo integrates virtual reality, machine learning, and real-time audio processing to create an interactive music therapy program. And by leveraging VR environments, users can engage in immersive musical experiences that facilitate emotional expression and anxiety management. The machine learning model adapts to user responses, which analyze vocal and biometric data to provide personalized feedback and support. And additionally, real-time audio analysis enhances user emotional state and engagement. And as development progresses, I hope to refine the algorithm, expand more on, just get deeper into the musical therapy aspect, because currently it's leaning towards vocal training, right? So just bridging the gap between therapeutic intervention and technological innovation. So these are some references that I used, along with some I linked a little bit earlier with Harvard Health and stuff like that. So thank you so much for listening. I have my email and then the code repo on GitHub. If you have any questions, I'm happy to take them. Thank you so much. And if you don't have any questions now, feel free to email me. Yeah, currently it's not on any app store right now, but I do have a website for it. Let me pull it up actually. It has like the download. I can find my mouse. Okay. Okay, well, I'm sorry, I don't have internet right now, but you can also just download it through my GitHub and just do it on your own application if you would like. Up to you. Yeah. Any last questions? Okay, well, thank you so much for coming, you guys. I really appreciate it.